All right, 5.2, quadratic functions in standard form. So last time we did vertex form. Another way that they like to write these are in standard form. So let me kind of, I guess, get started here and give you the skinny on this. So normally in standard form, it's written as y equals ax squared plus bx plus c. So notice that they put the powers in descending order. From 2 to 1 to 0. And it's just the coefficients that are in front. And those coefficients kind of help us find all of the pieces that we need. The axis of symmetry, the vertex, the y-intercept, all that good stuff. So we're going to be kind of referring to this as we go. Let me see if I can get most of these questions in. And may have to zoom out just a tad so I can get a lot of these on here. All right. So first off, when you look at your equation up top, it's nice to kind of figure out who the A, B, and C are. So A equals 1, B equals 2, and C equals -1. So there's no number in front of the x squared, but it's really A equals 1. So just kind of know that if there's nothing there, it's a 1. So here we go. So first thing we want to find is we want to find the axis of symmetry. And you just got to memorize this, but in general, the axis of symmetry is that vertical line x equals, and it's going to be -b over 2a. And there's a whole proof that goes into that, but for right now, just take my word for it. So to find the axis of symmetry, I'm going to do x, and so I'm going to put AOS for axis of symmetry here. And x equals -b, so since b is 2, that's -2, over 2 times a, which is 2 times 1. So it looks like x equals -1 is the axis of symmetry. So here in a minute when I come down and graph it, we need to remember that x equals -1 is the axis of symmetry. And now we need to find the vertex. So to find the vertex, well, we just figured out what x is. Now we just need to plug it in to figure out what y is. So we need to plug x into the equation to get our y. So up top, remember our y is that f of x value. So I'm going to plug this x in. So to find the vertex, we know the x part is -1. And now we just got to figure out the y part. So I'm going to go up to my original equation, and I'm going to do a -1 squared plus 2 times -1, subtract 1. -1 times itself is 1. That'd be a -2, -1. 1 minus 2 minus 1, I believe, is -2. So now we have a vertex at -1, -2. So step 3 is find the y-intercept. Well, remember, anytime you want to find the y-intercept, you're going to let x equal 0. Remember, it's always it's going to be 0. And it's really always just going to be your c value, because when I put 0 in for x, it wipes this term out. 0 in for the other x, it wipes that term out. And we basically just have -1. So our y-intercept, which is just going to be our c value, is going to be 0, -1. All right, so let me scroll down and I'm going to get this stuff on the graph here. So -1, -2, and 0, 1. All right, so we had a vertex at -1, -2. So -1, -2, there's our vertex. And our y-intercept was at 0, comma, and I think I actually messed that up. It should be -1. 0, -1, because that's what C was right here. And we knew our axis of symmetry. We got the axis of symmetry to be right here at -1. And so we can kind of find our other point by just using symmetry. We can bounce across the line here, and we can get that point. And now at this stage in the game, we can kind of play our normal move where we're going the over 1, up 1, over 2, up 4. over 2 all the way up 4. I want to put that dot there. And then if I wanted to go another one, which I don't really have to, but on the next one, remember, you were going over 3 and all the way up 9. So over 3 units to the right from the vertex, up 9. That's going to be all the way to here. And that's going to bounce and reflect across the line of symmetry. And we should have a nice little sketch of what's going on. Sorry, that's kind of on top of itself, but just made it a little bit easier. So I have the axis of symmetry, I have the vertex, I have the y-intercept. What we need left is we have to state the max or the min. So I think I'm going to clean this up just a little bit so we can see what's going on a little bit easier. So when I'm looking at my graph, since this opens up, I'm going to have a minimum right here. That's the lowest value possible. And that minimum occurs at y equals -2. That's the lowest that we can go. So there's our minimum. And now we're going to get into this domain and range. All right. So this is kind of something a little bit new as well. You probably did this in algebra. But the domain, and I think we actually did it earlier this year as well. The domain, it represents all possible x values. And the range are all possible y values. So in this function, I can put anything I want in for x. So the domain can be anything. So for my domain, and we want to use interval notation. We did this earlier this year. But the domain, I can put any x in I want. So it can go from -infinity to +infinity. Whatever x I want to plug in there is fine. But when I start putting all my values in a table, the range, the possible y values, well, because we have a minimum at -2, the lowest it can ever go is, it can be -2, but it can go no lower. So your least value goes on the left of your interval. It's kind of like a number line. And the y values are going to go forever. They're going to go to +infinity because these arrows represent that as long as I keep picking more and more x's, it's just going to keep getting bigger and bigger and bigger all the way till infinity. So this is kind of a concept we got to pull back from what we did earlier this year. And we're using interval notation. Some people use set notation, but we're going to stick with this one. All right, let's try another example. So example 2 over here. So I'm looking at this thing. It's definitely in standard form. One thing I might want to do is I might want to write down, A is +1, B is -6, C is +5. So the first thing, because A is a positive number, all right, this thing is going to open up. So it opens up. So I know it's kind of going to look like this. So I have a general idea of the U. And first thing I probably need to find is I need to figure out, what is the axis of symmetry? So for the axis of symmetry, and this is kind of the crucial part, it's -b over 2a. So -6 over 2 times a. So it's actually 3. So we have an axis of symmetry at x equals 3. And this doesn't have to be drawn on the graph, but I kind of just like to put it there for our symmetry lines later. So I have the axis of symmetry at x equals 3. I now want to get the vertex. So the vertex, I know the x value. The x value is 3. We got to figure out the y value. So what I'm going to do is I'm going to plug 3 in for x to my original equation. So we have 3 squared minus 6 times 3 plus 5. Well, that's 9. Take away 18 plus 5, not 15, plus 5. Which that's a -9 plus 5, so that would be a -4. So y equals -4. So now we have a vertex chilling at -4, right there. I know it opens up, so that's going to be a minimum value. So we do have a minimum at y equals -4. And just remember that this minimum value should be the y, and the axis of symmetry should be the x. So that kind of tips you off if you're doing it right. Well, since there was no number in front of x squared, I know I can start playing the game, you know, the 1, 1, 2, 4, 3, 9 game. So I could kind of start playing that game. But before we get too far, remember that, well, I might as well just do it, over 3 up 9. So that should put me to right here, and then reflect straight across over here. That also gave me the y-intercept. But remember, the y-intercept should just be at 0, c, which in this case, c was 5. So the y-intercept is 0, 5. And it checked out. That was the exact same place if I just did my 1, 1, 2, 4, 3, 9 game. Now I could sketch a nice little rounded curve. And I've got a parabola on here. And now we got to talk about domain and range. Well, the domain can be anything. There is no restrictions on x. I can plug in any x I want into this equation, and I'll be fine. Negatives, positives, 0. But for the range, I think we're going to be limited. I think the lowest point, remember the low goes on the left, the highest point goes on the right. We can drop all the way down to -4, but we can go up as high as positive infinity. So that's how that one on the left looks. Now, the one on the right, I threw a couple extra little twists in here to kind of show you some other possibilities of what could happen. So I'm going to erase what's on that side so we can kind of look at it. First thing I want you to understand is a is -2. So whenever a is negative, that tips you up that we're going to open down. We're going to look like this. Which actually, you know, the fancy way for saying that is we're going to reflect over the x-axis. That's what it means to flip down. And then we also are going to stretch by 2. We're going to stretch by a factor of 2. So all of that came from the a part. All right? Well, then we have the b part. b equals 4. And then we have the c equals -5. So remember, that's going to give me my y-intercept. So right away, that kind of tips me off that I have a y-intercept at 0, -5. So I can put that point on the grid. So I got some things right away that I kind of know what's going on. But let's get after this. So the very first thing I need to do is I need to find the line of symmetry. So the axis of symmetry is -b over 2 times a. So that's 2 times a, which is -2. So basically we have -4 over -4, which equals 1. So there's my axis of symmetry is at x equals 1. All right, so I'm going to sketch that line. And I don't know where the vertex yet is. You know, vertex form's kind of nice because I can just look at it and see. This one I actually got to do some work. So for the vertex, I know what x is. It's over 1. But now I got to plug that into the equation up top to figure out the y. So I'm going to have a -2x squared plus 4 times x minus 5. So I got to do the 1 squared is 1 times the -2. So that's -2 added to 4, take away 5. So that's -3 is what that all shakes out to be. So there's my vertex at 1, -3, right there. So I have my vertex. I have my y-intercept. I could reflect that point if I wanted to across the line of symmetry, and that gives me another one. And that kind of jives because remember right here where it said it was stretched by 2? Well, that means that normally, you know, if we're going down, normally it's 1, 1, and it's 2, 4. But if we're stretched by a factor of 2, we need to multiply these by 2. So really we're going over 1 down 2, which is exactly what happened here. You know, so if you kind of come to your little piece, we actually went over 1 down 2, over 1 down 2. Well, now we're going to go over 2 down 8. So we're going to come over 2 down 8, which is actually going to just fly off the graph a little bit there at 11. And we got to do it on the other side as well. So that's about all the points we're going to be able to get on this one. We're not going to be able to get any more points. So I'll kind of get rid of these little lines. And if I want to clean this up, it's going to be a skinny little parabola that opens down, and it got vertically stretched by a factor of 2. And I think let me see, we got a vertex. Oh, we got to say that we have a maximum. So we have a maximum at, looks like the highest it's ever going to get is at y equals -3. So now for the domain and range. Well, and I'll just shorten this and put D. For the domain, again, x can be anything. On all these quadratics, x is just going to be whatever you want it to be. But for the y's, for the range values, it looks like on the negative end, it can go as low as it wants to. So this thing is going to go forever down into negative infinity. It's just, the y values are just going to keep getting lower and lower and lower. But as far as how high it can go, it looks like -3 is going to be the cutoff. And I put that hard bracket to show that it can be -3, but it doesn't go past there. All right. So the big key to this thing is starting off with that x equals -b/2a. Kind of helps you out. All right, application problem. It says the highway mileage M in miles per gallon is approximated by, so we have a function here. So let's kind of write this down. M of S is -0.025 S squared plus 2.45 S minus 30, where S is the speed. So M is the miles per gallon. So basically this equation is, it's your mileage as a function of speed, meaning that when you change the speed, you change your gas mileage. Normally in a car, the faster you go, you know, as you increase your speed, your gas mileage goes down if you're flooring it all the time and driving all over. So that's kind of why this negative sign is in the front, because as S gets bigger, your gas mileage is going to drop more and more and more. So if we think about this, you know, if we think about a graph, and I'm not actually even going to try to graph this perfectly because these numbers are kind of big, but it says, what is the maximum mileage for this compact car to the nearest tenth? So, you know, maximum mileage. What they're wanting is they're wanting me to find the maximum y value. All right, so how do I find a maximum y value? Well, I find a maximum y value, I think I need to get the vertex. So we need to figure out what the vertex is. If I can find that vertex, that'll help give me a maximum. Well, remember, to find the x value of the vertex, it's -b, -2.45, over 2a. So over 2 times -0.025. All right, so I'm going to jam that into a calculator here and see what we get. So -2.45 divided by, I'm going to do parentheses, 2 times -0.025, parentheses, enter. I'm getting 49. All right, so x, and remember, so when I say x and y, this is really S and M, because the S's are in the x position. So an x value or an S value of 49. And now I need to figure out, when I plug that in the calculator, what I get. So I need to stick 49 in there. So that'd be 49 squared plus 2.45 S, which I don't know why I wrote S. That's another 49. Minus 30. So let me punch all this in the calculator. Negative 0.025 parentheses 49 parentheses squared plus 2.45 times 49, take away 30. I'm getting 30.025. And it says nearest tenth. So nearest tenth tells me I got to stop there. The 2 says leave it alone. So I think this is going to be 30.0. So it looks like that is going to be the maximum gas mileage possible with this vehicle. So on my graph here, if I was just going to kind of sketch this out, it looks like over here at somewhere at 49 and a height of 30, where this is gas mileage and this is speed, I'm going to have a vertex right there. I know that my y-intercept, remember the y-intercept is, which doesn't really make sense in this problem, because if your speed is 0, it's saying I'm going to get negative 30 miles to the gallon, because remember, it's just that C value. But nevertheless, to make the graph work out, it's going to be right down here at negative 30 if I wanted to graph it. So it's going to come up, and then it's going to drop back down somewhere like that. And this is just a model probably for, like, if you're driving, the speed limit, because it looks like if you get some speed over there, you're going to be like starting to go negative gas mileage, which isn't really possible. So then it says, what speed results in the maximum mileage? So I think that's the 49 that we found. So 49 would be the speed. 49 miles per hour. That's our S value. And when our mileage is 49 miles per gallon. MPG. Use a graphing calculator to verify your findings. So let's just pop up our graphing calculator here. And I'm going to pull up my trusty TI. And let's just punch this in and see what happens. So let's clear out, go to my y equals, I'm going to clear these two out. And the equation was y equals negative 0.025 x to the second power plus 2.45 x, remember that's like S, minus 30, and enter. Now we could graph it. First I'm going to check out the table. Let's see what my table's set at. I'm going to go second table set. And my table right now is set at negative 30. Let's just start our table at 0. And let's go up by ones. So that'd be, I'm going to start my speed at 0 and go up by ones. And I want to see what that table looks like. So I'm going to go second table. So remember, x is the speed, y is the gas mileage. So 0, negative 30, that was on our graph. And if we go down, it looks like for this model, at 15 miles an hour, we start to get positive gas mileage, which doesn't really make a lot of sense, but it probably only works for like between certain miles per hour. Now we're getting somewhere. So at like 30 miles an hour, we're up to 21 miles per gallon. At 40 miles per hour, we're still getting better miles per gallon. Getting better, 29.95. We're at 30.025 was our highest point. See right there? we got up to 30.025, and now we start dropping again. Our y values start coming back down, coming back down, coming back down. You know, if you're doing speed limit on the highway of 70, you're back down to 19 miles per gallon. So if I wanted to graph this, I could hit graph, and my window's probably not big enough. It doesn't really show much right here. So I know that for this problem, my speed limit's probably going to be like between 0 and 100. So let's just change our window, and let's go from 0 to 100 miles an hour by tens. And then my y minimum, I don't know. Let's just go negative 30, because we did know that was the intercept. And my max, I'm going to go up to, I'll just do like 60 by tens. And let's graph it. And there we go. We see our nice little curve. And we should be able to find that maximum. Now I'm just going to kind of play around here. But in that calc menu, so we go to second, trace, where we found intersect before. We want to find a maximum value. So I'm going to hit enter. And it says left bound or right bound. Well, wherever I think the highest point is, I got to go to the left side of that and hit enter. And then it says right bound. Now I got to kind of use my little toggler here to go all the way over to the other side where it's coming back down. And it's going to find the highest point between those two. Do I want to guess? Yes. And it says, oh, at 49.00000, we're at 30.025. So it did find the maximum for me as well. All right, hopefully this helps you out, get you ready for the practice. See you.